Okay, wow, hey, it's the next day, and I'm pretty excited. We're going to tune this radio up and be done with it. That'll be great. So we're going to hook it up to the signal generator over here. And we're going to run the signal generator at the IF frequency, which is 456. Instead of 455, who knows why. 455, roughly around there. Okay, volume down. Let's put the power on. There we go. Now, as I saw earlier, I put a short circuit across the on-off switch on this radio. So at this point, it's on-off with the power cord. I'll probably leave it like that. In fact, we're on restricted power. I'm going to put it on full power here. Why is this meter showing upscale? I don't know. It shouldn't be. It could be one of the wires is not connected properly. Nope, that's not the case. This is pretty sensitive. So I think I've just got the meter very, very sensitive. Quite interesting. I really don't know why this is upscale. I've got this meter connected to the speaker here. The speaker is isolated by a transformer. It can only have alternating current in it. I wonder if it's just possible. Let's try one thing. So there is a ground on the speaker circuit. Right there. I tried to figure out which I tried to get at that ground point. I can't really. So I put these leads on. This is normally a 3-prong instrument, but on this meter, the 3rd prong on the power cord is cut off. There is no 3rd prong. I checked it just before I turned the video on, reading resistance between the ground here, the chassis here basically, and something else that is grounded. There is no ground on here. Maybe if I switch these leads around, we'll get rid of that. Let's just try it. Easier to do it here. Worse. So I don't know. I don't know what that is. Make it go away to a large degree by doing that. Remember, this is a meter with no zero. There's never an actual zero on it. Now, why is it hopping like that? You got me. Okay, we'll leave it like that for now. Let's get the signal generator working here. I'm just going to feed the IF signal right into the antenna here. Hot diggity dog. Oh! I should have checked that. Very high level there. Volume up full. Now, this is, oh, it's already set to, well, let's tune it a bit. A little higher. A little higher. That'd be 456. You can hear a little bit here. Let's tune her up. Right, I turned all these adjustments here on the IF. At some point along the line, my frustrated hunt for the problem with the radio earlier. So this is probably, first here, so this is second. Wow, it dropped right out. Wasn't quite expecting that. Trying to feed in the weakest signal I can get away with here. Last bit was obviously done by ear because the meter's doing that again. Oh, look, this is set pretty high now. What is going on there? What is going on there? I wonder if they I was going to say, because this isn't grounded. It is grounded. It's grounded via this black wire here. Grounded to the chassis. That means one of these two leads, according to that schematic, it's not directly though. It's through either through this coil or through the hum coil there that I get to the ground from where I've connected these. So maybe that's a huge hum signal in there. I don't know, you know, I'm right across the voice coil, so whatever's there I should hear. It's very strange. But I don't know what to do about it, so I'm going to ignore it for now, because it's just another mystery. Let's try doing these two tune-ups. So what I'm going to do is I'm going to put this to the center, 10, right on 10 here. I'm going to dial up 10 on here. Oh, 10. Let's try 1. Okay. Turn the radio up. Hey, come on. We're on 10. 10 is connected. I already heard the signal come out of here. Why nothing? More signal. Okay, so we want to adjust the oscillator now, so we get that so we get 10 here, not what we have now. So what I'm going to do is put this to 10. That's where we want to go. One of the, wait a minute, gotta figure out which, wait, too soon. Okay, so one of these two is the antenna, the other is the oscillator. Which is which? So this one's up near this coil. This one's down near the other coil, which is lower down. So now that sounds like a tuning effect to me. And that sounds like an antenna effect. So this will be the oscillator here. So now we want to make signal. Now find it. Just passed. Okay, so there's 10. That's 10 now. 10 is 10. And now front end sensitivity, I think I can just carry on like this. Oh my gosh. Okay, what happened there? Wow, it seemed like this was way off. It seemed to almost be tuned in the quiet area. That doesn't make sense, does it? Okay, what's happening? Well, what's happening here? Picking up the signal generator. Signal generator is still at 1,000. Getting it at close to 14. Something's way out. So I expect to find strong signals in a couple places on a radio like this because of an effect called the image. But the image should be quieter. I can't even pick it up where it's supposed to pick it up. Okay, something's way out of whack here. Something is way out of whack. Either I got these controls mixed up, which I don't think so. Moved it a bit. Found it a bit. So this sounds the best. Way down here. Wow, can it be that far out? Can you even trim it all the way back to there? Just getting, really getting the EBGBs. So this is up around 14. Let's tune the signal generator up around 1.4 megahertz and see what we got here. 0.4. Nothing. Isn't that strange? It doesn't seem to matter how many of these radios I do, every one of them has something peculiar going on. Well, if we assume now that this is really where 1010 is, if this is 1010, 640, a real station in the area, would be up around here somewhere. So that's the IF. Why is it reacting way up here? 460. What happened? Okay, we'll ignore that little deal. Pretty strong there. Oh my gosh, what's going on? Getting it all over the place. Now that sounds like the strongest. Wow. Okay. So there's strong real signal at 680. Let's get this on to 680. Right on 680 here. Okay, that's close enough. So no, the radio appears to be tuned to 680 even though it says that. So we're going to switch now to a antenna. Just going to switch to an outdoor antenna, as poor as that is for listening to AM. I didn't hear a thing happen in this radio as I did that. Wow. Okay. Well, I don't hear 680. We have to give it a stronger antenna here. Or 680 down here. Okay, so we're just below 10. I can come back. Okay, this is a job for SDR radio. Okay, so in a moment I'll put the SDR display up on the screen. Right now I just want to show you what I'll be doing, because you won't see what I'm doing. I just have this coil. It's plugged into the antenna lead to my SDR radio, just in case you've never seen me do this before. Maybe you're new to my videos. Here's the SDR radio sitting here. We will be looking at the spectrum display from it briefly, shortly rather. Probably not briefly. There's a coil here, just acting as the antenna for my SDR radio. Okay, this is slapped together. There's nothing special about this, just stuff I had. And I'm just gonna poke around. I have a notion where the local oscillator frequency is probably airborne, so to speak, in this area. Certainly down around the oscillator coil down here. I'm just going to be doing this. We'll look at the SDR screen, see what shows up. Okay, so there's the SDR. Now what we're going to look for here is where the local oscillator is. First I'm going to put my hand around that coil just to double check. You can see a little change happening there on the screen. That's from my hand. Now I'm going to bring this up to right where I think the local oscillator is, and when I do that, I'll tell you when I do it. Watch on the waterfall display for a new signal. Okay, so I'm going to put this right here. I don't see any new signal. Okay, let's try right here. No new signal. There's something going on there, right just below, right around 1,100,000. Okay, let me try another spot here. Okay, just try all kinds of spots. Oh, there we go. Okay, now let's see if I can let go of this without shorting something out. Turn the radio up a little bit. So I'm affecting things by putting it there. I don't want that to happen. Oh, well, like that. Okay, what do we got? Let everything settle down. So just above 1,000,000, you see a fairly strong line. I'm going to tune the radio and watch for something moving around a little bit. What happened there? How come everything jumped? It's not from me tuning the radio, is it? Okay, so you see something moving along. It's now at about 950. Now it's going up. Not very big peak, is it? See, my SDR is picking up very strong noise signals still. It's really hard to follow or even see. So I have it, whatever that is, it's around 950. 950 is the end of the tuning range. So let's see, 950 minus 456. It's 500. So that's the bottom. So that is a local oscillator. I'm pretty sure we're seeing a local oscillator. So if that's the case, then when I put the dial onto 1,000,000, which I'm going to do now. Okay, so the radio looks like it's tuned to 1,000 kilocycles. Oh, where'd the local oscillator go? I lost track of it. Let me wiggle it here. Where'd it go? Okay, I see it there. Hey, everything just changed in this radio. Okay, so something probably happened with the SDR radio. That's much better. This is the way I want it to be anyway. So probably the SDR connection or something. So there we see the radio's tuned to 1,000,000 and the local oscillator, by my reckoning, is 1,300. Obviously there's some wire thing going on here. Let me just wiggle a few leads. Okay, I don't think that's the radio that's changing. That's me doing that last bit. Okay, don't know exactly why things suddenly changed on the screen, but 1,300 is way off. To be the radio's tuned to 1,000,000, then this should be at 1456. Okay, so let me turn that local oscillator adjustment. I'll show you what I'm doing here. I'm going to be turning this, and that'll move that local oscillator across the SDR. And we'll put it where it's supposed to be. Okay. So I'm in the screw, and I'm going to turn. So this is opening the capacitor. It was easy to get up there. No problem at all. So we're tuned to 1,000,000, 1456 is where this should be. Wow, okay, if I didn't use the SDR, I think this would be really tough to pull off. Now, I can measure that frequency using the SDR. Just put this line right here. Bring it down a little bit. So we're at, hey, that's exactly where we're supposed to be. Exactly. So the radio now is producing a local oscillator at this frequency. If it mixes with a signal at 1,000,000, we're going to get a signal at 456 that go through the IF. We should hear it. There's a station at 1010. Just above on the dial, but the radio should be fairly well calibrated. Let's check it out. Well, that was a great way to adjust the local oscillator. Now, so we're Still on the outside antenna, which is why we're hearing stuff. I can leave that in there. It's really not hurting the radio any. We'll see if we get 1010. This way, turn the other way. 1010's tough to receive. Nope. So we'll go down. Any station will do. Getting pretty quiet down here. Quiet, went right out. Right where the stations are. Maybe it's because of this. So I'll adjust the antenna trimmer. Look at that, eh? I found in the past that when I leave the ground off the antenna, I get a much better result. I think there's a voice there. Well, that would be 680 according to this. Let's go 640. It's a little stronger. And 590. There's a chance this antenna is not actually connected to the outdoor antenna. I am going to run and throw a switch as I've done before.
I'll be right back.
Barely hear it. Let's put on a much better antenna here and we'll see what we really get out of this. Okay, let's switch antennas here. So this is a loop antenna. You need to have both wires hooked up. The first one should produce some pretty similar. Now this one should go quiet. Ooh, the radio's doing something different again. Bit of an oscillation in it. So now I can hear what sounds to me like some kind of hum like going through the IF or something like that. I'm just making that up, but there's a garble in the voice. I don't think we're out of the woods yet. Not sure what any of that means. Seems like I crank this down too tight, we get that distortion. And why the heck would that be? Meanwhile, the meter continues to show on the 1 volt scale. 2 volts up there, I think. That's how you would read that, would you? RMS volts. 1 volt scale here. 0.7 volts. Coming from where? Let me turn the power off here for a sec. And a hunch. Yeah, see, it's still coming. So it has nothing to do with the radio itself. It has to do with how I've hooked things up. It could even just be a really bad wire here. Or maybe I don't have connection up here. I have to have a connection because... oh. No, I don't. Okay, so that's probably what's happened here. Is I'm not actually connected. Let's see. Hey, what's happened to my meter? What's happened to my meter there? Huh. Don't use the 1 volt setting. Don't know what's happened. Like that. You never know just where your headaches are going to come from. See if I can make a connection now onto the speaker here. I think I got it there. Wow, okay, where's the distortion? Oh, there's a little piece exposed there. This radio's still got lots of problems. Well, let's start doing stuff here. First, what's the B plus on this radio? It's only 97. Wow, that doesn't sound very good. 97 to the chassis. What about 90? What about right across here? $120. You know, that would be kind of okay for a radio without a transformer. This one has a transformer in it. You expect to find a couple hundred volts coming out of it here. Well, I don't know. It says plate 85. 93. 93. So, I'm mistaken. So, you know, if you're reading 8593 up here, you're reading essentially right on those capacitors. It's all the same. So that turns out to be the correct voltage, not the incorrect voltage. Let's double check it again. So it's pretty much dead on. Okay, now there's some shields in some of these tubes. There's a shield in here and a shield screen grid rather in here. So the screen grid I'm going to pick that up. So the screen grid follows right off the top of the capacitor here, the full voltage. I say screen, so the screen takes its voltage right off, yeah, right off the same line. There's a little bit of filtering right in there. 0.05. So if we find this 0.05, we read the voltage up here and get the screen on the other side of this 30K resistor. Now, I remember all this. I just don't remember where I saw all this. 30K. There's a 30K resistor right here. There's the capacitor to ground right there. I think that's it. .47, if I've done this right. 47 on the shield. Well, this is one of the earliest tubes. This is the first tube. It says 93, not 47. If I've done this right. Have I done this right? I think I'm reading. I haven't done this right at all. Where am I? I'm lost. Here we are. Yeah, so I am reading right near this tube. Basically right on one of the pins. Perfect. So I'm getting half the voltage here we're supposed to get. So let me back up and go across this resistor. We should see the full voltage on the other side of this resistor. That resistor becomes implicated. There it is. There it is. There it is right there. So again, one side. Expect to see 93 there. The other side is here. This very busy spot. So there's all the voltage available. On this side, whoops. 40, so, you know, 50, 90, is that a big deal? Does that say 43 or 93? Uh-oh. That's a 9. I can compare what he wrote here to the other places he wrote a 9. So, and the screen over here, it's hard to see. He's written something there, but it's illegible. But it's on the same line. They're all on the same. There's one single B plus line. Feeds both the plates and the shields. And then what they've done is they put in a capacitor to snuff out any shield signal. And they did not put a capacitor in here. There's no protection on the shield line going into this tube. Like they could put a resistor here and put a capacitor, just like over here. Guess they're thinking maybe is amplification is low enough now that a little bit of badness in here won't show up loud enough to disturb the speaker. A little bit of stuff in the first tube is going to get amplified all the way through. Maybe that's what they're thinking. So they spent the resistor and capacitor here, but they didn't spend it here. I'm not about to redesign this radio, so this 30K could be something other than 30K. let's just make sure there's no voltage across that resistor when I go to read it. 0. There was a touch there at first. You can't get much closer to 30K than that. So what would cause a wrong current through this tube? I'm assuming there's too much current in this leg, too much voltage drop here. Not enough, I don't know if this is true, I was going to say not enough negative voltage here, and that might also cause some of the distortions we're hearing. Incorrect bias here. Measuring the bias is tricky business. So bias is going to be controlled by this resistor, very much so. I should be able to see the bias voltage, certainly on the other side of this guy. I'm thinking as the meter's going to draw a bit, and you don't want to get past some of these big resistors, because then you're drawing through the big resistor. That won't give you too good a read. So I could try here, or I could try here, either one, around this 50K resistor. Going up into here. Oh, am I going to find that one? 50K. Oh boy. Okay, so that's going to take a bit. I'll hunt that down here. I did need to actually stop. I suddenly recalled this is a 50K, and the two filtering picofarad capacitors are hidden in behind here. They're just about impossible to see. So once again, let's check for voltage first. Okay, nothing there. Is it 50K? I can't catch a break here. That's, again, that's about as close to 50K as you can get. It's 1 megohm. Could be wrong. I think I measured this 15 megohm at 20 megohms. That doesn't really matter, I don't think. We'll find this guy and measure him. It's supposed to be 1 megohm. And I'm not sure I can remember where that is. There he is right there. I see him. So this is supposed to be a 1 megohm resistor in circuit. Get close to 1 megohm. Much closer than that. Just not catching a break here anywhere. Okay, here we go. Test of the 12A8. I'm going to test the tubes in the radio, see what we end up with. So we'll double check here. Filament voltage 13 on this machine. 1 on the signal. 20L there, 27345, 27345, 4610, 4610. Concentrator, Gem 32. C. Tube shorts. This isn't even on. Tube tester not plugged in? Yep, that's right. I found this a lot of the equipment I have has to be plugged in before it works. There we we go. Okay, just for fun, we'll do a little line check here. Go. Shorts. Nope. Okay, we should be reading 750, which that's 1,000, so 750 is right there. Beauty. Beauty too. That's one done. Okay, let's try 12K7, 12K7, 13 voltage 2, 33L 17342, 17342, 0610, 0610, 42, 43 rather, D. Good to go. Good cat. Okay, check for shorts. So 12K7 should be above 1,000, so it should be over that number there. Way over. She's a thing of beauty. So far, this isn't helping out one bit. Okay, well, we're going to try the. As I put this one back, we'll try the 12. I think a 12Q7 next. Okay, here we go with the 12Q7. 1, 23L 27300, 27300, 0610, 0610, 48, whoops, 12Q7, 30, 30, F. So we're testing, this is a multi-part tube, so it's got a triode and two, or at least one diode in it. So this is the triode test. Oh, I'm not going to get anywhere with that. So I have two tube deals I'm working on from two different people who've got some tubes in the background. Yes, I'm going to try to buy more tubes, or get more tubes. Maybe not even buy them. Okay, short. No shorts. Okay, mutual conductance on this should read 780. 780, and it's going to be right around there again. There we go. That's like 800, so it's above. Okay, it's not a humdinger. Now the next part is a diode. Change these numbers. 2703P. 2703P. 0610, 48. A. Make sure we get that correct. P1, P2. There's two diodes in this. This tube. Okay, checking for shorts. No shorts. So now we're checking on a diode, so we want to throw this switch. Diodes are good above this line here, where my finger is. Ooh. Right on the line. Okay, so what I do in cases like this, I like to check the sensitivity of a couple things, especially this meter sensitivity. So I'm going to do that. I'm going to turn this control. Well, it doesn't get any higher than where it is. There's a fair bit of sensitivity here, but so this guy's on the line when it comes to diodes. Does that really matter that much? I think all that could really do, particularly if they're kind of okay when on the line, is at the very least, or the very most, just weaken the signal a little bit coming out of the speaker. I think it passes. And I don't think I have a replacement for any of these tubes are just a little on the odd side. Well, radio's a little on the odd side. Now, is it worth testing the output tube and the rectifier tube? Can that cause any of the weirdness that we're getting? I don't see it. I do not get it. Once in a while when I pull tubes out and stick them back in, problems go away. I pulled the shield off that tube at the back there too. So let's let this thing, let's let her run. Let her run. Loop antenna engaged. Volume down. Full power. Just full of noise and full of that stuff. I took that shield off. Wow. So what happened since the last time I ran this radio?
Directors, the administration, the faculty, and the entire St. Michael's College community fully support these arrests. We absolutely believe the horrific incidents of sexual assault. These incidents are clearly indicative we have a problem. A serious problem. As a school, we have a responsibility to keep our students safe. Our collective best efforts have failed.
There's a private school in Toronto, and there's some rather terrible abuse going on between the students. As it turns out, serious enough that students, high school students, are being arrested for it. And it's just thrown this private school, highly respected private school, into a gigantic tizzy, as you could imagine. So everybody's upset. Everybody's upset. So that's the story there. Okay, I feel I got to throw a little background sometimes when there's news stories playing on the radio and you're listening. You might be from Sweden or somewhere and wonder what's going on in Canada. The main thing is, again, Canadians upset, postal strike, marijuana deliveries are late. So that's that's our big issue here, along with everything else. Okay, I got to stop at this point. really, I gotta reconnoiter the situation. I thought I'd be winding up this radio today in 15 minutes. No. Thanks for watching.